Assalamualaikum warahmatullahi wabarakatuh. Good morning, everybody. In the second panel session, we are going to have great presentation from two great presenters. All right? Okay. I'd like to ask you when, because the time has been running for 20 minutes, should we add 20 minutes because it should be finished at 12 according to the time schedule? Should we add 20 minutes? Yes or no? Okay. All right. Depend on the situation later. Right. Before starting the discussion of presentation, I'd like to read the biography of two great presenters. The first one, Professor Hans-Dieter Bach from University of Muenster, Germany. He was born in Kiel, Germany, and then he got PhD in Didaktik der Chemie, or in English, chemistry education, at the University of Hanover, right? And then he was the professor at the University of Muenster, Germany, and then he was retired, has been retired since 2013. All right. And then until now, he was very active as senior expert services, keynote speaker in seminar and chemical education at Riga Technical University, Latvia University, and then University Vienna, and others in Austria, yeah. Leuven University, Brussels, Belgium, University of St. Petersburg, and Indonesian universities in Bandung, yeah, Malang, Singaraja, Surakarta, Semarang, Indonesia, Western Michigan University in Kalamazoo, and then University of Toronto, Canada, and many else. Right. The second presenter, Profesor Agus Suyatna, Magister Science. Yeah, he was born in Banjarmasin, 21st August 1960, and he was a PhD or doctor in physics. Yeah, in physics. So we are going to have great presentation. The first one, chemist expert, and the second one, physics expert. Okay, and
much for the Revolution 4.0, but for progressive education. You see, my title is the sub-micro level progressive education for understanding chemistry. You must know I went through Ethiopia, through Tanzania, through Indonesia, and I heard every time that the full equation is written, but not the particles are mentioned which are reacting. I don't know. I think now only the chemistry physics teacher may understand me, but I will show you some new researchers from Asi Visudavati. She is now 3 years my doctorate in Muenster, having a state scholarship, arriving beginning of this year, and we will see what she has done. Here first I have some photos. Here is our United Germany, and here is my town Muenster, near the Hollandish border. And very shortly we have a good inner town. Many tourists are coming across because after all was bombed in 1945, we built it up in the old style with old photos, so that the town of Muenster is a very much visited town. This is Norma von Surakarta. I will visit her on Tuesday. She was 3 years ago, did her dissertation, and our way is to ask her 2 hours questions about chemistry, me and my follower, Mrs. Maron, and the psychologist and the pedagogic professor is doing this also. And then all the community is coming. Even my wife was this day there to say hello to Norma finishing her PhD. Yeah, my education is a little written in this book, and the main thing is I know that chemistry education is not a linear process like something in mathematics or in physics. So I took this round picture. I start most my my presentations, my lectures in one semester, 2 afternoons, learners' ideas, misconception, 2 days experiments, 2 days structural models and to develop mental models, to interpret experiments, and to write it shortly by our formula and symbols. Everyday life, media, motivation, teaching aims are also around. So this is my plan to teach chemistry education at our university. And my most work have been on structure-orientated concepts, means that I could see that when the students just go from substances to formulas, they have to memorize, as I could see it in Tanzania, Ethiopia, Indonesia. So I inserted models of the substance. I can show one example. Here I modeled the structure of sodium hydroxide, sodium chloride. You see, every white sphere represents a chloride anion, and the red sphere the sodium cation, so that the students can see that it's a big, giant structure going on and on and on. Some experts are taking this cube out, this is into the structure, and are defining this by this cube. It's okay. You see the coordination number 6 for both ions, and you see that there are no molecules. I will show you in the next slides the biggest misconceptions in chemistry, because students are seeing formula like NaCl and are thinking on molecules, Na bonding Cl. And when we have to have progressive education, as our title is telling it, then we must switch to ions in salts. To visualize the structures by a reaction, maybe I have one example for you. When carbon reacts with oxygen, you get CO2, carbon dioxide. And when you show those pictures to the students, or let the students draw their own pictures of the reaction, then they have more information as only by the formula. I will show you examples where you can see it better. Later on, Johnson came with his triangle. I don't know, you have heard of the chemistry triangle. And Johnson also pointed out, when you go from the macro level, from the substances and reactions, just to the equations and formula, the students memorize and don't know why Al2O3 or why CaCl2 and so on. Take the submicro level with atoms, ions and molecules and show what those particles are doing. I will give you examples. Here, for example, the neutralization reaction, which you all know, the chemistry teachers all know. You see by this painting, the H3O plus ions of hydrochloric acid are only replaced by sodium ions. The ions remain, the Cl minus is not doing anything, the Na plus is not doing anything, only the H3O plus ions and the OH minus ions are reacting to H2O molecules. When you have such a painting, it shows more than only the equation HCl plus NaOH. I was in classes and asked which particles are reacting, and they cannot tell me anything about ions. Although they know the ions because it was 11th, 12th grade, and they don't apply the ions for such reactions. So because of those many misconceptions, I gave my students the task, please look to classes 7 until 13 by chemical reaction, by redox, by acid-base reaction, by energy, what they have, what misconceptions in which area. And I found at first a very important thing. There are two kinds of misconceptions. You cannot avoid that young girls and young boys are bringing their observations from everyday life. Let's say an example, combustion. They see a big bunch of wood or paper burns away and little ashes remain. Of course they are thinking paper is destructed totally, it's away. They cannot see the oxygen which is reacting, they cannot see the CO2 gas because it's invisible, and the water steam which is reacting. So they have has in mind something is going away. And our big task in school is to make a conceptual change from the everyday life thinking to the scientific thinking. And that's not easy. When you have 10, 12, 15 years, have seen combustion, have seen copper is changing to a green color, you must instruct them what happens. You must instruct the oxidation theory that oxygen is reacting and carbon dioxide is formed, like in my slide before. Yeah, when you instruct this way, the slide is away. There was the slide about here it is. When you instruct them that there is oxygen is coming to the carbon and carbon dioxide is formed and the masses left and right side are the same, then they understand chemistry. So the first thing is there are misconceptions from young boys and girls. I call it preconcepts because it's not a mistake. The bigger problem are the school-made misconceptions. In everyday life, you hear nothing about equilibrium or redox or acid-base reactions. But there are mistakes, by wrong teaching, by when the topic is too difficult maybe, so that we see many school-made misconceptions by our research. Scale is going down. Iron oxide is heavier than the iron before. So you have to tell something about iron. Gray iron changed to black iron oxide, and this is of course heavier. And even when Mrs. Driver take a stopper on a closed flask with oxygen and phosphorus in it and ask what is after the reaction of the phosphorus, student point out less than the mass before, nothing in the container could escape, but the smoke has dissolved and phosphorus destroyed, making it way less. When you don't see the phosphorus, they think the phosphorus is away and that must be way less. You must teach them that the atoms by this reaction are regrouping to new molecules, P4 or 10 molecules, and then they understand the chemistry. But even when you inform them about formula, I went sometimes 30 years ago in a class 10, had only 1 hour to do something. And I asked them about magnesium combustion. Yes, they say, we know it, of course. Mg plus O gives MgO. We have learned it by our chemistry teacher. Then I asked, what are the particles, the magnesium particles, doing through combustion? And one student really answered, magnesium contains 2 kinds of particles. One evaporates, the other one remains as magnesium oxide, and did this nice painting. In an element like magnesium, he put 2 kinds of particles. One is going to space, I don't know where, and ashes are remaining. So he has his old thinking in mind, and the teacher has not made the conceptual change. So you must have 5 or 10 examples for those burning problems that the student has the chance to change their thinking from childhood, from there is something going away. So it's not easy to do this by students when you only have them 2 hours per week. The schoolmate misconception here, Sopandi from Bandung, I will visit him in November. He asked students in Muenster, with the help of German master students, what particles are in mineral water, after informing them that sodium chloride and calcium chloride, magnesium chloride is dissolved. And 25% were right answers. They answered in grade 10 and 11 with ions, calcium ions, sodium ions, chloride ions. But 70% about have molecules in mind. They wrote this here, this here, this here, and even here Mg2Cl2 molecule. You remember the molecules which are not in sodium chloride are mentioned, and the students have a misconception which a teacher has produced. The teacher must point out, think by calcium chloride on Ca2 plus ions, Cl minus ions in the ratio 1 to 2. Think of aluminium oxide by Al3 plus ions and O2 minus ions in the ratio 2 to 3, and so on. You must write the ions into the compound Na plus Cl and not only NaCl. Just because they know other molecules, they come to misconceptions about those molecules. Now the studies of Asi Visudavati from Yogyakarta. She took her data in Yogyakarta before coming to Germany and developed a questionnaire giving students a full equation and asking for particles. I may show you first the kind of questions. Here you see, she asked the reaction of magnesium metal with hydrochloric acid and gave all the students the well-known equation. The chemistry students know this, chemistry teachers know this. But asking about the particles, they are Mg atoms from magnesium, they are H plus ions from hydrochloric acid, and they change to Mg2 plus ions and H2 molecules. You see, this is the answer of the question, which particles are reacting. And if you want, you can have the electron redox reaction as electron transfer. The donor particle is the Mg atom, gives 2 electrons. The acceptor is the H plus ion, takes 1 electron, 2 H plus ion, take 2 electrons, make 1 H2 molecule. Or here, acid-base reaction, she is all the time asking about the particles, and it was hard to find this solution. Mostly the students have MgO in their mind, and with MgO you cannot define acid-base reaction. You must remember Brønsted, 1928, defined acid and base molecules or ions which are giving protons or taking protons. You must go away from substances. And when I ask sometimes Norma in Surakarta, she told me that you are mostly talking about substances and don't mention the particles. You are not going on the submicro level for interpretation, and you see by the submicro level all is much clearer when you have the proton donors and the proton acceptors. So this is the work of Mrs. Asi Visudavati, and you see most redox reactions have been identified by oxidation numbers, but they don't could tell her which particles are giving electrons, which particles are taking electrons. Same for acid-base reaction. They marked acid-base in the right way, but couldn't identify proton donors and acceptors. And all the solid salts were described by these formulas, and we have to make interviews later to ask if they really mean the molecule or they don't know that those substances are made up of ions. You can all read this in the African Journal of Chemical Education 2019. When you open AJCE, you find the whole questionnaire, can apply this questionnaire for your students and can see how good they are in redox and acid-base reactions. This is in Germany and in Tanzania. It's okay, I can switch it, but there's another problem what I'm discussing with Dr. Yuli from UNJ University in Jakarta, where I just stay for the next 2 weeks. She gave a questionnaire to students with laboratory jargon. I will give you another example. Sometimes the chemist experts say 2 hydrogen and 1 oxygen react to 2 water. Because the other expert knows he means 2 H2 molecules and 1 O2 molecule. But when we go with this laboratory jargon to young learners, they will ask, what are 2 hydrogen? 2 gram, 2 milliliter? So the terminology is a very bad terminology, this laboratory jargon, and the chemists can do this. They know the story behind and they can tell this in short information. But with the learner, we have to go the scientific way. So her example is here, hydrochloric acid gives off a proton. The expert knows there is meant the H3O plus ion in hydrochloric acid solution, which is giving the proton. So she asked, which of the next scientists is the right scientist? This, or this? The right answer is H3O plus ions are present in hydrochloric acid. They can emit protons. And this answer was only given, this is task 2, by 15% of your students in Indonesia. And Dr. Yuli was very disappointed and will do other lectures according to the particles which are reacting. You see other questions are better, 63, 83, and so on. The full questionnaire is this, in this publication, what I mentioned. So try to avoid this laboratory jargon and try to be by acid-base and by redox reaction on the way to mention the particles which are giving up electrons, the particles which are giving up protons, then you're on the scientific right way. Okay, that is what I showed. Yeah, one last slide. Our doctorate, Hilving, developed this periodic system with atoms, the blue spheres, and ions, so that the students must accept we have ions. They are not only atoms with ionic bonding and all those things that I heard. And they tried to combine the salts about ions on the left side and ions on the right side, and even students in the grade 8, grade 9 classes, they take, let's see, calcium or magnesium ions, and when you ask about magnesium chloride, they say, okay, the Cl- ion is 1-, so I must take the magnesium ions and the Cl- ions in the ratio 1:2 to have equivalence of plus and negative charges. With this periodic system, my wife, by the way, chemistry teacher, is teaching students when she has only 1 hour per week, because they shorten the program, have no teachers and so on. So she introduced, when you combine the blue metal atoms, you get metal crystals, like this model here. When you combine copper atoms, it's a sphere packing, like you pack these cellulose spheres together. The nature is not doing more than packing copper or gold atoms together in this way, and this is a cubic centered packing, and they have an understanding that metals are crystals, and the same way with the salts. When they combine the ions left and right, they get ionic lattices like this here, to go away from the molecular vision of the students. Okay, you can have molecules. When you combine right, H atoms and C atoms, you get CH4, N atoms and H atoms, you get NH3, and so on. So that with this program, you have a short introduction in chemistry, but the students know a little bit about the structure of substances, about the structure of material, even in everyday life, and they understand chemistry. I have the last 2 minutes? Okay, then I will go to the end. You see, for all who want to know this, I have some handouts for chemistry teachers. Then you can look to baking powder and so on. When you want to know before you start your lectures something about misconceptions, you can go with these concept cartoons. Here, someone is asking, what species are present in hydrochloric acid? Are that HCl molecules and H2O molecules? That's the wrong answer. Are that HCl AQ particles? Are they H plus Cl minus particles? Are there H plus ions and Cl minus ions and water molecules, of course? This is the right answer, and I have observed that students like to discuss, no, I think this is right, I think this is right. And they discuss as long as more and more the right answer comes out, and you can diagnose the misconceptions of students before you start your classes. And after you have 4 or 6 weeks spent for education in acid and bases, you take the same concept cartoon and ask again and see now 90% of students have the right answer. The same for what is going on in the neutralization. Are there HCl and NaOH in the same amount? Are there Na plus Cl minus ions and H2O molecules? Are there solid NaCl and H2O? So you offer most researched misconceptions, and look what kind of misconceptions your students have. You can even have a fifth person and can say my imagination, and your students can find new ways to interpret the neutralization. Before lectures, you make the diagnosis of misconceptions. After the lecture, you see if the students have grabbed the right idea. That is one possibility to have no new misconceptions, to have no school-made misconceptions. I will repeat, you cannot avoid the preconceptions of very young girls and boys. They are bringing this from everyday life. But we can avoid school-made misconceptions by good teaching, by teaching on the sub-micro level. This was my little wish and a very concrete presentation about chemical education. Thank you very much.